Okay, I'm Brian. I don't know if I need to do too much of an intro because I just did a half-hour talk about myself and what we work on. But my favorite robot that I've had a chance to work on, I would say this is maybe like not a super interesting one, but just UR5 in general. It was the first robot that we had. It still works. It's like rock solid. We don't have to do much work on it. I'd say as much as I think hardware has made huge leaps, it still can be a huge pain. And the specific UR5 that I know has been like great. So this is my favorite.
All right.
My name is Fei. I'm a research scientist at Google DeepMind. I've also been working in this field for more than 10 years. I started working on foundation model plus robotics. I worked a lot with Brian before. He introduced me to this field of foundation model and robotics. We did some of the pioneer work in this field, including PalmSecAnd, PalmE, RT1, RT2. So now I'm still working in this direction. I think now is a great time, and we have seen these models doing very cool dexterity and generalization tasks. My favorite robot is one robot that I built in 2014. It's a robot called Tinker. We brought it to RoboCup. It's a very janky robot. The localization is basically using a mouse dragging like on the floor, but it works. Like it's one of the first mobile manipulators that we have built, and yeah, it brings a lot of memories.
Yeah, I can directly use the Mac. So I already introduced myself with a talk. I will directly jump into the interesting question about which is the most interesting robot I worked on. So different from you guys, I'm actually a new, people enter this space, like because before Dyna, I was co-founder of a company called Caper, who is building smart shopping cart, which you can also see as a robotic system. Apart that it cannot move by itself, so mostly it can only detect stuff. So I will see I think the Caper cart is actually my first robot that I actually applied a lot of perception algorithm onto that system, and finally we make it scalable for grocery items to be identified. So that's kind of my first and favorite robot that I built. And then after that, I entered this space, I saw much more fancier robots. So yeah, I'll keep on working on that, yeah.
Hi. Is that a yes? Hi, everyone. I'm Roz. I'm the founder of Tuesday Lab. We build a delightful robot that will clean your home for you. I'm tempted to say Spot. I worked at Boston Dynamics on manipulation for 4 years, and I love the Spot robot, but my favorite robot is the robot that we're currently building. It is so cute, and it is so cool, and I can't wait to have one in my home.
Cool. Awesome. All right, so the way we're going to structure this, we have some mysterious amount of time for the panel, anywhere from 30 minutes as originally scheduled to 30 plus some amount of time. So I have some questions prepared. We'll chat for a while and then try to leave some time at the end for audience questions. So, but if there's anything that's like really burning in your mind, please raise a hand. Feel free to call out, whatever. I want to make sure that people have a chance if they want, but if you can wait with your question until the end, we'll make sure that there's some time at the end too. All right, so first question. So as I'm sure all of you do this also, I spend maybe too much time on X, and there's just like a constant slew of amazing videos in robotics. Some of you have made these videos, and these videos can like show all sorts of capabilities. And sometimes, you know, in the middle of the night when I'm watching these videos, I'm like, oh no, robotics is solved. There's nothing else to work on. And so I guess my question is, what do you think people should take away from these kinds of videos and demos? And also, maybe it's kind of silly to ask because we're all up here, but is robotics solved?
Let's see. So it's not solved. I think there's a number of challenging problems. I think the big takeaway for me from some of these is that there are signs of life, that there are algorithms that scale and have the ability to solve these types of things. And in limited domains, when you control the setting, we've shown that neural networks can ingest this data and produce fairly complex manipulation demos, navigation demos, locomotion, the whole kind of gamut of things. But I think where they start to fail is, again, like generalization, understanding new scenes, and then particularly on performance. So getting to like solidly 100%. I mean, I think even we've made progress from 80% at things to 90% to 99%. But the last time that I failed folding a t-shirt was like never. And so there's still something there, and we need to figure out kind of how to solve that. I think that's one of the big ones. And then, I mean, there's a number of other very unsolved problems, but this to me it's like really signs of life and encouraging. But
yeah, I think I've been watching a lot of this video too. One thing that I want to remind everyone is like people usually have overestimation of what the technology can do in short term and have like underestimate what the technology can do in long term, and that applies to watching those like wonderful demos on social media too. What I would look for, what I'm impressed by, is how some of these demos demonstrate behavior that it is impossible to hard code, impossible for human to program. And when like these demonstrate some of these more emergent, more human-like behavior, I think that's really, really cool. And I would also say some of these demos are very much cherry-picked or very much staged. Cherry picking usually have a bad reputation in like academia. However, I think it's maybe like fine for generative AI because it shows there is a solution in the solution space. You're basically measuring pass at 100. With enough work, it can bring that to pass at 1. So that's where the technology really matures. And so we should have the right amount of expectation for these type of demos.
Yeah, so I hold really similar views with you guys, which is I think the video part is more to describe a possible, like a possibility in the future. So it's more about what we can do, but it's not about like what we can do now. Some are like, yeah, but for example, for my company, like we try to shoot the video in a way that we are kind of confident on the constant performance. But again, it doesn't mean that like it always works. Sometimes it still fails. I think this video just can give you more imagination on what things can be done in the future. Yeah.
Retweet. I think it's all been said.
Cool. So if videos are not the way to measure progress, then how should we be measuring progress?
we can start that way. So
Yeah.
How should we measure progress? I measure progress in deployed robot systems. So I think we're still in the dark ages in terms of mobile platforms that go into the world and meet us where we are.
Yeah, so we host similar metrics, but we also care about ARR. That's like the most obvious metrics for company. So finally, that's why like Dyna focus a lot on deployment, because we really think the whole industry will be a very, very long run. It's a marathon, right? So like at these days, I know all of us probably get a lot of funding from different institutions or whatever, but finally, as a company, we need to actually land product to production and make money and provide value for our customers. So I think that's the most important metrics we are looking at.
Yeah, I think the ultimate way to measure performance is on an end-to-end system. Like the reason that's why we are over-indexing on demos is we don't have a robot at home, right? If we have a robot at home, I should be able to directly download 2 policies and compare them side by side. And that should be my ultimate way of comparing those. We start to see some signs of life from Pi, for example, like on open source, open models. But I believe like when this becomes commoditized and when we democratize this technology, the gold standard is basically A/B testing, where compare two policies. I guess there is another thing that we measure performance is developer satisfaction, because sometimes you don't develop the final product, but you build a open platform and people can build on top of it. So developer will basically give feedback on whether some of these are good.
Yeah, I mean, I think, as you said, like really getting it out into the real world is like the most important thing. You need to be able to interact with it, understand for yourself the limitations. I think there was so much we learned with language models once they were out there and you could actually like chat back and forth with them. You get a much better sense about where they are. I think we're still in this point where they're starting to show signs of being able to do this, but they're not quite there. I guess the other area that I think, and maybe I'll just turn into an area of research that I think is super important that we as robotics have not solved, is evaluation and offline evaluation. I think we don't even have metrics as a community to be able to solve these kind of things, and I think that's an area that like we really need to sit together and figure out what's the best way to be able to track progress as we go in a more quantitative sense, and I think this is going to be really important for the field going forward.
Totally agree. I have two follow-ups. But okay, so first, in order to reach this kind of broad deployment, what are the big things that need to be solved? So you know, we have big models, and they work pretty well for language. But what's left?
I mentioned earlier, and a lot of us are thinking about it, but just getting to this 100% performance is like, even in fairly narrow tasks, I think is like a clear kind of elephant in the room. Speed is also really important. The ability to interact with people, but I feel I'll leave more.
I would say like solving the robotics problem is a small significant part of solving the robotics product. And so I think that getting to 100% is important, and then recognizing failure, knowing how to account for failure, knowing how to report that up the chain, that sort of thing is also really important. And that all is premised upon like, I've found something valuable for my customer, they are willing to pay the price for it, and they continue to derive value that exceeds that price through the lifetime of the product.
Yeah, I think on top of all this like model robustness related topic, we also like robots is a very different product because it's a pure like physical hardware. It's very different from ChatGPT, which is a purely online digital. So to actually get like make the last mile for the robot to be deployed successfully, how to design the overall hardware system to make sure it's robust at the foundation, it's also very important because you don't want like the hardware itself behave in a very like crazy way, right? So also like how to support this hardware, make sure like all the like consumer electronics, like how to support it, how to maintain it, that's also very important for deployment.
Yeah, I think safety is still a big consideration, like for those robots to be deployed, and maybe hardware cost. It's getting lower and lower, but to reach the mass production, to really reach like the majority of the population, I think it's still somewhat prohibiting.
So with this, I think you kind of you named the thing that I wanted to ask about next, which is safety. And I think that one of the things that we talk about a lot in robotics is the necessity of getting things into homes, and that's a way that we can measure progress, but a way that we get things into people's homes so that we can measure progress and so that we can make progress is that the things have to be safe. And I guess there's a lot to talk about here, but one of the things that I'm curious what all of your thoughts are is, do you think that capability and safety have to come together? Do you have to design safety before you design capability? You know, if what you want to do is collect data in people's homes, and then you need to make sure that the robots are safe, but maybe they can't be safe until you have that data. What is that? What is the shape of that flywheel?
I mean, I think capability and safety are for sure at least correlated. So, I mean, I think performance is there too. Being able to do something at 100% means to also be safe while doing it. So it's the ability to understand what you're doing and to know what is safe and isn't safe. I think one thing that is really nice about this wave of, I guess, machine learning techniques is that they can understand safety in a very broad sense. I think previously when we talked about safety within robotics, it was like constraints and mathematical formulas. But the understanding that you can't put a certain item on something because it'll melt, or the more nebulous safety that we actually deal with every day and that is important for being deployed in the real world, I think a lot of it actually is going to come from these foundation models that actually already have an understanding of this. And we need to figure out how to make sure that all the data that we ingest is able to learn from this as well. So I think I see like a nice kind of future for safety where we actually understand more fundamentally what it means to be safe.
Yeah, I guess on the one hand, there's seeming to be a kind of Pareto frontier of safety and capability. Like, for example, you can have a system that always punt, always like refuse. That is perfectly safe, but it's not capable at all. On the other hand, there are some positive correlation which you can reason about safety and that can help you become safer. So the approach that I would advocate is probably a Swiss cheese type of approach where you have multiple layers and each of the layer can help you filter some. Like for example, the first layer should be semantic safety, and then there are physical safety, and finally on your firmware, on your hardware, like there are some additional safety. One thing that we had before is that the robot has a finger that can fall off, right? It's a compliant finger, and if it apply too much force, it will fall off. So that's your kind of final layer of safety. It cannot apply too much force to the environment.
Yeah, I guess you guys talked all I want to say. Yeah. Do you have any?
Yeah, I guess in terms of weighing capability and safety against each other, and then I would even add, like we've talked about, like what is the experience of interacting with the robot? Where does delight enter? I would say capability or safety is table stakes. You know, like you can't enter someone's home if it's not going to be safe. Capability is the reason to buy and keep a robot. And then delight is the user experience and user loyalty. I think that enters on day zero. I think what level of interaction you want to have or want to be capable of having has to be a part of the conversation. For us, we don't want to automate any human-to-human interaction, so we want to make it easier for you to live your life and interact with the humans around you. We think of the robot sort of interacting at the level of a cat, you know? It's there, it's cute, it's got its own mind, it's got its own world. And that comes into play in how it behaves, and it also comes into play in like our conversations about what level of language the robot should have. So we're thinking a lot about what is the minimum amount of language that this robot needs in order to be able to interact with you, because I don't think it needs to speak English fully with you. Hello, or whatever your native language is. So I think that reducing that surface area for interaction is pretty important. And I think that like you can think about your cat, again, like you might talk to your cat about your ex-boyfriend, but your cat's not gonna call him and tell him what he did. So that's kind of the goal for the robot. Also, I'll add, hello, that like we see these relationships form really readily. Like people name their Roombas. At Boston Dynamics, I remember I was giving a demo to someone and they were driving the robot themselves. They were joystick driving the robot. It had no autonomy on it. And they drove it into the wall and they looked at me and said, oh, he wants to drive into the wall. And so I think people really readily cast their own intelligence onto these robots, so you don't have to do a lot of that definition for them. So that's what we're designing for.
Yeah, I think that's very interesting opinions. So for Dyna, currently we are still focusing more on a lot of like commercial environment. So we haven't like stepped really deep into the emotional part, but at least so far our design are also converging more towards some pet format instead of like very humanoid, because we really feel like a lot of times people are treating robots more as they are like a company, not as another person, right? We don't want to bring another person into, like, for example, your home, just standing there, and you can, it's like you have a servant for you, right? So that's why, like, we made some design choice that to make the robot looks a little bit more cute instead of like more similar to human. But that's just very shallow opinion on that. We're still focusing more on like the capability part at the moment. Yeah.
Yeah, I guess the question of a robot should be your companion or a robot should be a tool is a very cultural question, and I think it's very deep and philosophical. I share a similar view. Like, so far, we mostly care about capability. So the human-robot interaction is also for capability. Like, I want to clarify your need so that I can better help you. So that's like the current, we're not touching the emotional part. And I guess, like, personally, I'm thinking about, I have a couple of robots at home. Should I name the robot? That's, I guess, a practical question. And I guess, like, just from my own opinion, like, maybe like Asian parents, like, we're very strict about things, right? So I'll probably say, if you can fold the t-shirt 100% of the time, I will give you a name. Like, otherwise, you, I wouldn't, like, give you a name.
I'll just agree with Faye there.
Great. Taking a step back, I guess, and Faye, you kind of were talking about this a bit, but as you're thinking about these systems, there seems like there's a big trade-off, or maybe not trade-off, between like capability, performance, safety, and fun. Do you think that by necessity you have to focus on each of these one at a time? Do they all come together? Do you have to be explicitly thinking about the trade-off between those? And if so, how?
I think mostly I think they're actually like the same. Like, it's really like intelligence is kind of each of these, that safety capability. It's like robustness to settings, to understanding what it's doing in the environment, how it's interacting with people. I think all of these are sort of one and the same.
What about fun?
Fun too. Maybe not industrial robots, but I think like fun in the settings where fun makes sense. I think this all kind of stems into safety, and I think really you shouldn't just look at one of these axes, or you'll probably kind of overfit. And this is why we are going for much more of a like long approach on intelligence. But I think when you do it correctly, and you see this within foundation models, they don't necessarily have too many to make a choice of we're going to do this or that. There's maybe a little bit in what Faye said about this like Pareto frontier, where you can kind of tune how willing to answer it is. But I think in the long run, if it's truly intelligent, it understands when and it should and shouldn't answer and how it should answer.
Yeah.
Cool.
So.
No.
Yeah. I think all these dimensions also relates to what our final product you really want to deliver, because different product actually will emphasize the different area, like what Brian just mentioned, like industry robot, you don't want it to be fun most of the case, right? So it's also the same for any product design, which is you need to understand what is your target, and then you can design the related like personality traits into that. That's what we think.
It's funny, I feel like I use a lot of productivity software, and the ones that are more fun are like way nicer to use in like an industrial category. So I don't know.
Which ones are fun?
I think Notion is pretty fun. Like, I like the little drawings, and it's like really fun to use Notion.
I like the unicorn that I get when I check off a task in Asana. I don't know if you guys are familiar.
I mean, I feel like fun has a place in an industrial setting too. Okay, so kind of in this, like, you know, are we doing things one at a time, or are we doing things together within that theme? On the topic of capability and performance, do you, and maybe this is maybe this is more of like a personal philosophy question, but do you think that as we are designing general purpose intelligence for robotics, assuming that's what we're doing, do you see capabilities coming sort of one at a time or in a staggered fashion, or do you see kind of everything getting better all at once and like suddenly, boom, we will have a robotic system that can basically match a human performance across every task that a human would do, you know, at some age, like, you know, 3-year-old, then a 5-year-old, then an 8-year-old or something?
I can probably start this. So, because when we start our company, we focus a lot on kind of express a narrative about like learning from one skill to like expand skill by skill. But as we are actually expanding the data set and try to tackle more tasks, we realize that actually like it's kind of interlinked with each other, which is once you have more data, then you also kind of get a lot of things out of the box from your pre-train, from your like larger model, better weights. In that sense, then it's also possible there's a way that you can master a lot of stuff all at once you have the correct data combination. So we're not too strict on which direction we're moving forward. But finally, I think that's like both direction you can get some good results with both direction. Yeah.
I can maybe also speak to this a bit. So I think the model will have some baseline capability that is just coming from pre-training. So this is borrowing a page from the book of like how language model and vision language models are developed. So the model just to learn from internet scale data, it will have some baseline capability to, let's say, carry out a conversation and help you do some tasks. And then the tasks have high economic value, are artificially enriched in the pre-training. So for example, like coding, right? It's a highly valuable task, so that got improved really quickly. So I think that might be similar in robotics. Like if we don't do anything, then all the capability will grow at a similar pace, but there are some tasks that are economically valuable and they will be prioritized, they will be enriched in the data set, and we'll see some of these come first. And then like those will transfer to other capabilities.
I think that's true. I think maybe the most like core salient thing for me though is closer to how language models, like at first people might have been working on a language model for directly translation or a language model for legal software or like very specific use cases. And the model that took over in the end is just this pre-trained model that is very general, that has seen a wide range of things and thus and transfers across this. And so in the long run, I think the model that generalizes as much as possible, can ingest as much heterogeneous data, is the one that will probably kind of win out. And so I do see this rise of the floor together and probably some like emergent capabilities that suddenly, oh, it understands this, even though we didn't train it to do that, in the way that language models have surprised us within context learning or other, other abilities.
So building off that, is the main thing that's just missing is more data?
I guess the thing that I can point to is like if data was the only problem, then Tesla's self-driving car would have been solved years ago. They have essentially like more or less infinite data of real people in real scenes using the car in a certain way, and yet it hasn't been solved. I think there are certain ways in which robotics can be much more optimistic than that. I think there's like broad algorithmic improvement, but I don't think it's just data.
I think we touched upon some of the challenges already, like performance, safety, like these are big challenges and maybe cannot be purely solved by data. And even if we believe data is a big blocker, there are still lots of gain that you can get from like learning algorithm. And how do you train this model and deploy those models?
Yeah, I think how to actually leverage all this data is actually very important, because the robotic data is, because right now a lot of people are trying to replicate whatever the language model has been achieved so far and apply that to the robotic models. But we need to realize that language model data by nature is much more structured than the robots data, because like language is, first of all, it's a man-made stuff, right? So it's already artificial. And then when you write down on internet for any like written text, you already like kind of filter the language. It's much structured than you're like verbally communicating something. But for robotics data, it's very like unstructured in a way that like you see the 3D world, you also have like a lot of random actions. So the data itself, the nature is also very different. So if you only by increasing the volume of the data without any, let's say, like model structure change or any like methodology change, then there's a possibility that this way won't work, because currently the only working model is language model and plus like kind of VLM type of multi-model stuff. But so we're not too sure if that's if data volume is the only issue. Maybe there are also more improvement on the model itself to actually better congest all this data.
I agree with everything that's been said. I think there's also a really interesting business question here about how you deliver value with what's possible today so that you can collect more data and continue to build on that. I think like the Tesla example is apt, and also Tesla has a huge, unfair advantage in the autonomous driving space because they have all of that data because of the way that they've structured the problem for themselves. So that's one way I think about it.
I want to add a little bit. So like now we do need to collect data, but we are not collecting the data in vacuum. We already have all the language data or the images data. So how do we collect data in that context becomes a question. Yeah, so that's an additional things we consider.
So why do you think that all that data doesn't work for Tesla?
As in,
like what more is there to the problem?
So I mean, I guess there's the main thing is like algorithmic improvements. I think probably need to come with it. You could start out with just like a standard neural network and get so far, which is imitation learning, get so far with RL and maybe improve upon that. I mean, I think if I had like the full answer, I would go and tell them.
That'd be great.
But
yeah.
I think they're like clear algorithmic issues that are still challenging. Yeah.
Interesting. I think this question of economic viability in order to collect more data is very interesting, especially because if what you need for robotics is, if at least part of what you need for robotics is more data, amassing a data set that is wide and varied in the way that a language model data set seems quite challenging. Do you see this as being the business of individual companies, or is this like similar to Tesla, or is this like some sort of shared effort that has to happen across the industry because different companies will have products that are economically viable in limited domains and therefore can collect narrow types of data? Like what, at least in the medium term, what is the path towards amassing that kind of data scale while we figure out the modeling that needs to happen?
I mean, I think it can really go either way. It can, probably at some company getting enough data of a variety of sources that it becomes useful, and then through that, the community kind of contributing and building a much wider and wider data set. I think as we get to certain capabilities, these robots being deployed in the world then drive some like flywheel of improving data, improving amounts of data, new tasks being possible, and then being able to deploy in a new place. So I also think like fundamentally, this like idea of data actually is like can build into this positive feedback loop that can expand like crazy. But whether it's like a single company or a community, I think it's unclear and maybe remains to be seen. I think we've seen some like real benefits with like OpenX, for example, that hopefully will continue. But
yeah, I think the concept of getting like different parties to contributing to the data set is definitely good, but there are some realistic hiccups when you're actually trying to consolidate all different sources. I think like everyone, even let's say Google, the RTX you guys working on, the data format, how you actually ingest all this data, how you actually normalize them, that's like a big challenge. I do think like have the cross-source type of mechanism is important, but we do need more tooling to actually make sure all the things that you collect can be like in some way that's easy to be utilized. Otherwise, the chaos it creates may outweigh the value it brings. So that's a caveat.
Yeah, I guess there are like algorithmic challenges about combining the data sources, and like before we figure that out, I think just naively mixing data set doesn't make too much sense, and yeah, doesn't help too much. But there are open research questions that people are working on.
So I think one of the things that's interesting about robotics and different from AI models is that there's like an additional artifact of the product development life cycle that can be invented and sold and turned into a product. In that there's like an actual physical robot, and so in the way that a lot of language models have been trained on similar data sets, I'm wondering, because robotics has this additional step, do you see models as being something that might be shared between many different companies, and the ultimate thing that is sold as a product is the robot, or do you see like models as being something that are owned by individual companies separately?
I think it remains to be seen. I think that even in the language model space, that it's much more developed. There are the foundation model companies, and then there is immense value being created at the application layer. So I think the equivalent application layer here might be, a robotics company that uses pies models to drive, their robots, and I think that's could be one way that this all shakes out. I think that if there's a moat for Cursor, like a supply chain surely also only compounds that.
But there could also be like an application company that uses Tuesday's robot and gives it a new skill, right?
Yeah, I think that's really interesting.
Cool.
Yeah, I think we can see this from two perspectives. One is a model structure is like one version of what we call model, and then the model weights is actually another one. It's like all of the human, we have brains, right? But all of our brains internally are different, right? But the structure is the same. Everyone has the same structure brain. So I think ultimately the model structure will kind of converge to some like best practice, similarly to language model. Like right now, although there are a lot of different models, but to be honest, the structure are very similar. But the major difference between all these different models are like what type of data you train, like what specific capability you want to inject into the model to get it be, for example, expert on in some area. So I think like weights level, it wouldn't be like one single model that's like shared across all the different use cases, but architecture will definitely like kind of converge finally. Yeah.
Yeah, maybe just briefly, I guess if we look at the field of language models, I expect we also need kind of a similar scale to handle this like very complicated problem. I mean, We don't know the scaling laws. We don't know if it's what order of magnitude we're going to end up with, but I expect, dexterity I think is really hard, and it's really hard to learn, and the diversity of the world, the number of things that you can encounter, it's not all through this one, with a chat interface. There's a very fixed interface. There's much less of that in the world. So I think probably the sizes of these models and the amount of data they require is going to be extremely large in such a way that it probably, at least my first order thinking is that it looks like language model. There are a few people serving extremely large models and who are specializing in that, and those who are specializing in applications is where I expect it kind of ends up.
Cool. All right, I have one more question, and then I want to open it up to the audience. Where in this technological life cycle do you think we are? Like maybe using self-driving cars as perhaps the only successful robotic product out there, as a meter stick. Where do you think we are on our way towards having reliable robots that we can get either in our homes or for general purpose industrial applications?
I mean, I think it can be very hard to directly mirror the two. I think the bar for a robot doing something useful in the world is a lot lower than the bar for a self-driving car. I think a nice way to think about it in my mind is like, you have to be 16-year-old to drive a car, and you have to go through this whole process. It's like one of the few kind of, as a society, processes we have that restricts how people do it. A robot going in and loading and unloading my dishwasher, doing laundry, the bar is much lower. And so it just, like that makes it very hard for me to say where we are. I think, as I kind of said in the talk, that we're still a bit away either way. Now, putting it to a number where we are in self-driving cars is very, very challenging for me.
Yeah, I guess I would say maybe they will take very different paths. Like we probably shouldn't mirror it to like self-driving car. In some aspect, like it's more advanced because we have already figured out large-scale data collection, like imitation learning, language model backbone, like these type of things has already been figured out. On the other hand, there's no unified hardware platform, unlike cars. So in some aspects, it's like that part still need to be figured out, and like it's way behind self-driving cars. So it's really speculative, like hard to predict how this will come. Yeah.
Yeah, I also think it's a little bit hard to describe the actual stage because no matter it's autonomous vehicle or like large language model, I think right now the robotic space are lacking like one thing that like they kind of leverage a lot, which is for autonomous vehicle, you can drive a car without intelligence, right? So that's already a tool. For language model, you can pre-train on the existing internet data that's already there. But for robot, we have nothing. Like we have some open source data set, but the volume and data quality compared to those type of data are much like lower, so that like we kind of start from scratch. And for that two industry, probably they never had that phase at all. Like at day one, GPT-1 can just crawl the whole internet and try pre-train on it. But for us, like even we want to try, we don't we have nothing to try. So like we are kind of in a stage that's like there's no mirror you can directly link them. Yeah.
Yeah, I think the funny thing about talking about robots this way is that like robots have been around for a long time. There's the old robotics joke that anything that has been made is a machine, and anything that hasn't been made yet is a robot. And so obviously robotics hasn't been solved. I think I think robots will be delivering value in the home before we see pervasive autonomous vehicles on the roads.
Cool. All right. Now, any questions in the audience? You get the great privilege of being close.
Amazing. So we talked a lot about the quantity of data and the lack of available data, except for maybe in the case of Tesla. And that got me thinking, you know, one of the problems we have in medicine is not just the quantity of data. Sometimes people think about the quantity of data as a proxy for utility of data. But if you're not measuring the right things, then that data is not that useful. So I just was interested to get the panel's perspective on how do we make sure that as we're starting to collect more and more data, that we're collecting the right data for the outcomes that we want to drive towards.
Yeah, maybe there's like two areas for me. One is if we're actually delivering value in the world, then I hope that that kind of like, you can draw this direct line from this data, it's creating this value and is being useful, whether it's monetary or people or something, people getting enjoyment out of it. I think that's one really nice way to do that that's kind of like holistic. But we're still a little far away from this, and that's where I think areas like, can we sort of algorithmically tell this is novel data and useful data? And there's a lot of research into this, but I think that this has enabled language model companies to do a great job of adding in data, generating data, and making sure through some pipeline that it's going to be helpful to the end-to-end model. And so I think we, as kind of like researchers in this area, have a lot of work to do to get to that point, but there is some like proofs of concept that we can kind of figure this out algorithmically.
Yeah, I think, as I mentioned before, adding more tools to kind of unify the data collection process, that will be definitely helpful. And also, we internally design some like algorithm that can directly detect some data quality issue for us. So that will also be helpful. But again, like as robotics is a very diverse space, like it's not like autonomous vehicle, you are trying to avoid everything, right? You're just avoiding. But for robots right now, we're trying to interact with everything. So the possibility of the environment is much more different. So I think, again, like as data diversity expand, you always need to put more effort to actually ensure each piece of data is still correct, and the metrics will be different, so it will be a little bit customized.
And one of the fun parts about working on this problem right now is that you can use like large models from other areas like language models, vision models, to help you with your data machine as well. So we're just benefiting from all of this, you know, in so many ways, not just on robot.
I saw you move up.
Thank you. So at least 3 of your company's vision is developing generalist policy. But before we achieve that goal, are there milestones? For example, before we achieve AGI, we have general coding agents that can replace most programmers. What would be the roadblocks, major ones, that you could give some example of for us to look forward to before the technology matures?
Yeah, I guess that there is not such, well, I think in robotics it's very difficult to create such a thing. The main reason that like people believe code can be the platform is because you can use code to represent a lot of things, right? You can use code to represent graphics. You can use code to represent simulation. But for robotics, it's very hard to say what is that, right? Is that, yeah, I cannot think of an analogy for that.
I think a funny and interesting way to explain this is a lot of companies using coding as a milestone or metric because right now coding can generate the most revenue for them. I think that's very important. As a company, like we also want to find any scenarios that we can actually mass roll out some type of robot that's doing like relatively general thing. Because in the last trend, a lot of robots are already like mass roll out to a lot of factory, etc. But that's not general, right? So we still want the new robots to roll out to the space that require generability. And then we see that kind of as a small goal, although those areas may not cover all the use cases in the world. But if there are some areas, for example, right now we're working with some hotels, then in hotel you have a lot of things you want to do, right? You can fold napkins, you can fold whatever like sheet or any other stuff. You can also prepare food. Although that you won't require a hotel robot to do something that's at your home, right? So, but if we can actually large roll out in hotel, then we'll also see it as a major milestone for like next level AGI thing, yeah.
All right, maybe two more.
So lately, some people talk about world models, right? Like I think Demis talked about it, right? NVIDIA touts the Cosmos and things like that. What's the role of world models? How do you get the right data? Like in theory, okay, you can learn to dream YouTube, but it has no actions. Is the actions what's missing? How do you get the actions? Like, what's your take on this whole area?
I can probably go first. Yeah, we did some research on this part also, because one model, if it can be successful, it will be very powerful tool to generate unlimited data for us. But so far, I think there are several major challenges. One is, even for video generation models, right now to simulate the very strict physical things is still very hard because the like when it's video models learning from all these YouTube videos, all these videos sometimes doesn't follow physical law. For example, if you are like watching some like auto-generated video, something that's not necessarily need to follow any physical law, right? So, but again, there's another direction, which is we try to use very strict math and physical-based engine to generate videos and then feed it into this model to let them learn. But that becomes a little bit overkill because so far we don't have any engine that's that strict, right? So, and to generate a lot of different things with that engine will also require a lot of human labor and costs, like crafting all these things. So that becomes really hard. So finally, so far, like the world model, I don't think it's lacking the actions, but more lacking the understanding of the actual physical world. Although, like, I agree with probably more and more data, this can be better, but so far, I think there's still a challenge there, yeah.
Yeah, I mean, I think like many of these models, we're still missing this like low-level dexterous data that actually is like manipulating the world at that level. They're just like, even like YouTube data doesn't necessarily capture this. So I think there's a lot of the role is in robotics and collecting this type of data. That being said, I do think they're like extremely promising. Essentially, if we look at vision language models and what we've been able to transfer knowledge from them, it's mostly semantic concepts. It's this object or this object goes there or something like this, but it's not like movements and low level. And that's because, essentially, you know, they're trained on VQA and bounding boxes and detection tasks. So you're really just transferring that type of semantic knowledge. I think world models represent a potential way, if they can be trained on a wide variety of data, to start transferring much more deeply. So maybe it's not all the way down to dexterous data, and we still need robotics data to do it, but I think we can close the gap even further and start to transfer a lot more, start getting task generalization, motion generalization.
All right, one more.
Hey, so at least a couple you mentioned that you're trying to solve the dexterous manipulation problem, and as many of you have mentioned, like your primary setup is bimanual arms. You mentioned Aloha. What's your take or your company's sort of hypothesis on the embodiment gap that's going to come with advancements in end effectors? So say like as arms get better, or hands specifically get better, how does training data in today's world translate to a world where end effectors are significantly supreme versus what we're training on right now?
I mean, I think we'll be able to still transfer a lot of concepts. I think this data will be very valuable. The real key to me for any of these more complex end effectors is just how do we actually collect data with them? I think like there's hardware breakthroughs for them, but if you can collect really high quality data in a similar way to what we're collecting with bimanual manipulation, then I think we're going to transfer a lot of it, and we're actually going to be able to learn from it fairly effectively. But I think the gap is really in the collection right now.
I think it's a really interesting research question about how do you get dexterity, especially like dexterity with finger. It's becomes a big operation challenge because those are expensive, it's easy to break down. So yes, so I think this is an extra challenge.
Yeah, I think the gap actually exists. So right now we are most of us probably still use 2-finger gripper, whatever. That's just like based on costs and also the capability that we need at the moment. But in the future, let's say 5-finger hand can be very, very cheap and also very dexterous. There will be a time that probably we need to recollect some data. I don't think so far like all the data like is all transferable, but a good portion of them can still be useful. It's not like you have to abandon all of the data. Yeah, so because if it's only the gripper change, then at least your arm part and your like mobility part will all be the same. Yeah.
Yeah, I agree. I think I see cheap, robust 5-finger grippers as like as far off as like totally generalizable multi-embodiment models right now. So should be solved, right, guys?
Yeah.
All right, I think that's a wrap. Yeah, thanks so much to our panel.